Hey guys, today we're going to talk about average atomic mass. So we've learned that the mass is the number of protons and neutrons, but there are times that that mass is not equal to the number on the periodic table. So the atomic mass is protons, neutrons, and electrons, but we ignore the electrons because the electrons have such a small mass that they don't actually affect the overall atom. But we can have many forms of different elements called isotopes. These are elements that have different masses than the periodic table. So for example, there are two different isotopes of copper atoms. One type of copper weighs in at 62.93 atomic mass units. It makes up 69.1% of the atoms of copper on the planet. The other has a mass of 64.94 atomic mass units. This makes up the remaining 30.9% of atoms. So we have two distinct masses, 62.93 and 64.94, and they make up two different percentages of all of the copper atoms on the planet. So if we use that previous example, we can calculate the average mass of all of the isotopes of carbon. In order to do this, we have to take account all of the isotopes and the percentage of each, and we have to calculate what's called a weighted average. So our average atomic mass is the first mass times that percent, plus the second mass times that percent, so on, until we have all of the masses accounted for of the different isotopes. So this little n just means that we can have infinite number if there are that many isotopes. So again, our average mass is mass 1, which is 62.93, times the percent 1, and this percent is 69.1%. I'm going to change that back into decimal form, so 0.691 plus mass 2 times the percent changed back into decimal form. And since there are only two types of copper, those are the only numbers that we need. So as we calculate 62.93 times 0.691, this first value, I'm going to write it over here in green, is 43.48. The second value, 64.94 times 0.309, I'm going to write in green also, is 20.06. And when we add these together, we get a value of 63.54, which should match the number on the periodic table. So essentially, the number that's on the periodic table underneath copper is 63.54. That is the average mass of all of the copper isotopes on the planet. So the periodic table is actually telling us the average, not every single individual copper atom. So let's try that again. We're going to take the atomic mass and multiply it by the percent. So here we have 27.98 and 92.2%. So atomic mass is mass 1 times percent 1 plus mass 2 times percent 2 plus mass 3 times percent 3. And here we only have 3, so I'm going to stop there. The average mass is 27.98 times 0.922, changing that percent back into a decimal, plus 29.98 times 0.047, plus 29.97 times 0.031. Now as we calculate this through, this first value is 25.79. The second value is 1.41. The third value is 0.93. And when we add those up, our average atomic mass is 28.1. And if we look on the periodic table, it's about 28.08, so we round it a little bit. Now, if we look at these numbers, we can just do a comparison to give us an idea of where our average atomic mass should end up. So since the first isotope makes up over 92% of that abundance, our final mass should be closest to this mass. And it was. 27.98 and 28.1 are very, very close. So looking at the percents, we can determine which one affects the mass the most. One more practice problem. This time we have 4 isotope masses. So average mass is mass 1 times percent 1 plus mass 2 times percent 2 plus mass 3 times percent 3 plus mass 4 times percent 4. And when we do this, we take the mass, 53.9, times the percent changed back into a decimal, plus 55.9 times the second percent changed back into a decimal, and this last one is teeny tiny, changed into a decimal. This first value is 3.18, second value is 51.27, third value is 1.19, and the fourth value is 0.1624. And when you add those all up, our average mass of iron is 55.8 atomic mass units. Now that should make sense because looking at our percents, the highest percent is 55.9, so our answer should be really close to 55.9. So tomorrow in class we're going to practice calculating with average atomic mass using different isotopes of different elements. So I'll see you tomorrow so we can get to work.